So here we're talking about the normal density curve. We just learned the rules about it. And now we're actually going to try some examples. How are you going to use the normal density curve? And basically what is the interpretation, with the mean and the standard deviation? We're going to be talking about these things. So we have a lot of examples of things that actually are normally distributed. You would call them normally distributed. If you take a bunch of data, you graph them, you get a normal distribution. Normally distributed things like heights, if you measure all the heights of people pretty much, you measure like 100 million people in the US, you just take a gigantic sample and measure their heights, you will get a normal distribution around whatever the average height is. Also IQ, it's pretty famous for being normally distributed, probably birth weight, something like that. I'm sure that you could think of some other ones, but in this case, this particular example we're looking at, this one is talking about the heights of 10-year-old males. It tells us that they are normally distributed with a mean of 55.9 inches and a standard deviation of 5.7 inches. So we're supposed to draw the normal curve. Well, we already have one here, but we learned that the mean should be in the middle. So 55.9 inches, you should put that value here. And then standard deviation of 5.7 inches. So we're imagining these dotted lines right here. It's kind of implied that if you go over by one standard deviation, that's how far to get to this dotted line. And then one more standard deviation, one more standard deviation. So on this side, we have 55.9 is the mean. If you subtract the standard deviation, you take away 5.7, that's the value that you will get here. So 55.9 minus 5.7, that should be the value. It goes 50.2. So this would be 50.2 inches. And then what if we take away, what if we take away 5.7 again? That will give us 44.5 inches. So we go another standard deviation to the left, that would be 44.5. That will go here for this dotted line. On this side, we would add the standard deviation. So in the middle is still 55.9. If you take that one and you add the 5.7 inches, which is the standard deviation, we will get 61.6. So that's the value that we should put here, 61.6. And then if you add, say for example, another standard deviation, then we will get a height of 67.3 inches. That's the one that corresponds to this dotted line. So basically you could do that as many times as you want, going to the left and right. Of course, there's not many 10-year-olds that are going to be, going way over here like 7 feet tall or whatever, but that would be the parameters that it wants us to label for this one. Now it's talking about shade the region that represents the proportion of 10-year-old males who are less than 50.2 inches tall. So if you were following along, 50.2 inches, that was one standard deviation to the left of the mean. So here is basically the dotted line that goes with 50.2 inches. And then we're just interested in shading this little area. This is the area that corresponds, and it really keeps going to the left all the way. Of course, by the time you get so many standard deviations to the left that you're at 0 inches tall, it's not even possible at this point. And we will pretty much realize that this area, the reason why it wants us to shade this one is because of what this question is asking about, part C. It says, suppose that the area to the left of 50.2, that's what we just shaded, this area, suppose that area is 0.1587. We're supposed to interpret what that means. Well, just remember, the area under the whole curve is 1. And with the normal distribution, the area is the probability. Always remember that one. The area is the probability. So if we found that the area of this little part is 0.1587, then that means that this number is the probability that a randomly sampled 10-year-old, which it doesn't tell us, where they're from or anything like that. So just these 10-year-old males, the probability that you will sample one and you'll find a male who's less than 50.2 inches tall, it's a probability of 15.87%, or else they just write 0.1587 as a decimal. So that's just a probability that someone will be this tall or less. And we will see some more examples about how to use the normal distribution.